In this episode, the brutal truth strikes again.
I mean, nobody's going to go to a data center and configure thousands of boxes manually, right?
Then, Murphy enters the chat.
What can go wrong will go wrong at that scale.
And finally, some famous last words.
It better work, yeah.
Welcome to Cisco Tech Stories, a podcast with real-life stories from real-life engineers. Your hosts are Nicholas and Tristan.
Welcome to today's episode of the Cisco Tech Stories. We're diving into Sonic, the open source network operating system that's transforming cloud and data center networking. Sonic stands for Software for Open Networking in the Cloud and is built on Linux.
That's right, and Sonic is hardware agnostic and modular, running network function as Docker containers with centralized database for communication. It supports advanced feature and supports AI ML backend networks. Today we're excited to introduce JC Rode, Principal Engineer in Cisco XR Business Unit, who will share his insight on Sonic architecture, use cases, and Cisco's role in its development.
JC brings deep expertise in network operating system and will help us understand how Sonic is shaping the future of cloud networking. So stay tuned for an in-depth conversation about this powerful open source platform.
Let's get started. Let's welcome Jean Christophe Rode. Hello, Jean Christophe.
Hello, Tristan. Hello, Nico.
Hey,
Hello.
Nice to have you here. Do you mind introducing yourself a little bit?
Sure. So I'm Jean Christophe Rode, also known as JC. I work in the BU escalation, supporting Sonic and still a bit of iOS XR, mostly for our hyperscaler and large customers who have big data centers and using Sonic for these data centers. For the career, I started working at Cisco in 97. I joined as a graduate. That doesn't make it us any younger. That was the first batch of graduates at the time that Cisco Tech was hiring. So yeah, before that they were hiring experienced CCIA people from customers and partners. And at some point it was the beginning of the internet boom, if you remember, and they started hiring graduates. So I was one of them, started taking tech cases for some time, learned a lot, did a lot of tests in the tech lab. And then when my escalation engineer left like 2 years later, basically I took his place. I became escalation engineer for, at the time, what was the router architecture team. And I've been escalation for the team for a few years. And in the router architecture space, there was one device I really liked, was the GSR, which was the big service provider router. So I kind of specialized into that box and worked with the big service providers which were using this big box. And it was running iOS, but then around 2003, 2004, we had this new operating system called iOS XR that came in with the CRS, and that was our new router for service providers. And I jumped on that new technology, iOS XR and the CRS. I went back to taking service requests just to learn that new technology. I spent some time with the business unit, with engineering, to troubleshoot issues with them. And then I became the escalation engineer for the iOS XR team for quite some time. I saw the CRS in 2004 at FCS. Then a few years later came the SI 9000, the NCS 5500, the NCS 6000, and then the 8000 with the Silicon One. And that was it until like 4 years ago, I got someone calling me, asking me whether I would like to join the other side of the fence, the engineering side. And I said, yeah, look, I've been here for 25 years. Why not try to see from the other side? And I joined the BU escalation team. At the beginning, I thought it was to support mainly iOS XR, but that was the time when Sonic was starting to be deployed. We had now Sonic running on the 8000, and I said, well, look, that looks interesting, something new after so many years on XR. So I said, well, let me get involved. And I learned Sonic on the job, and since then, I'm kind of fully busy with Sonic, and that's super interesting. I like it, and yeah, I'm pretty much doing Sonic full time now.
I have to ask, what is Sonic in the first place? Because I had never heard about it before.
Yeah, Sonic is kind of the open source network operating system, NOS, for routers and switches. So it's the Linux of networking, if you want. Traditionally, we had proprietary operating systems on our switches and routers, Nexus OS, iOS XR, you name it. And at some point, some customers said, well, look, why do we have to have our management tools and so on be rewritten each time we deploy a new vendor? And they said, well, if we had one network operating system running on all our switches from across all our vendors, that would just be one set of management tools, and that would be so much easier for the training, for the management, and so on. So it's really an open source operating system for routers and switches, basically.
Why is Cisco busy with this? If it's open source like Linux, why do you get involved?
Because below Sonic, which is the platform independent part of the box, there is still a hardware box below, right? Mm-hmm. There is the 8000 series family, which are the switches that we deploy with Sonic. And for these boxes, we need two kinds of software. We need some what we call the BSP, the base support package, which is basically all the drivers for the environmental stuff, the fans, the power supplies, and so on. So these are the drivers, the FPD, the field programmable devices for the FPGAs and so on. So we need to support the box. That's one part, the environmental aspects. And then there is the big part, the NPU, Network Processing Unit, which is switching the packets. For this, on our boxes, on the 8000, it's the Silicon one, which is the NPU switching the packets. And for the NPU, then, of course, Sonic needs to program the NPU. And that's where the magic happens in the middle. There is some APIs which are called the SI APIs, which are basically the interface between the platform-independent Sonic and the platform-dependent NPU and its SDK. There is a SI layer in the middle that translates the platform-independent object creation, like I want to add a route, I want to create an interface and stuff like that, the stuff you know about networking. There are APIs to program this into the NPU, into some platform-dependent APIs for the NPU SDK. And this is the SI layer in the middle. So there is still quite an important piece of software at the bottom, which is the BSP and the NPU and SI, to translate the platform-independent Quest from Sonic into our proprietary code at the bottom of the stack.
And so that layer, that driver layer, is still Cisco proprietary, right? That part is not open source.
Yes,
okay.
Yes. This is our code, and this is mainly what we support. Now there are multiple support models with Sonic. The huge hyperscalers, the Microsoft Azure and those huge customers with huge data centers, they will be able to support Sonic by themselves, build their own image, and we will just support maybe that layer at the bottom with our code. Now there are smaller customers that would say, well, look, if I got a BGP issue, which is the Sonic platform independent code, who's going to fix my BGP issue? Is it? I mean, I can open a GitHub issue and hope that someone will fix that FRR bug, but it's not. I mean, I have no guarantee if it's an urgent bug that someone will fix it soon. So they will ask Cisco to support it fully as a whole and support the complete stack. And for this, that's also something we do now. We have full Sonic images that we publish on Cisco.com, and that will be supported by the Cisco TAC and by our Sonic team. And we will support Sonic end-to-end from the bottom to the top.
So we do fixes in the Sonic image, even like it's not Cisco operating. And then competitors also benefit from those fixes, right? Because everyone.
And we retrofit, we uplift the fix to the community, and Cisco is now one of the top 5 contributors in the Sonic community. So yes, definitely we are a key player now in the Sonic community. Yes.
So I was going to ask, what's the point for Cisco to even engage in that? Because typically, proprietary operating system, you have proprietary features, you can say we're the best, blah, blah, blah. Now, customers demand it, so we provide, but then you still have the argument that you have a service contract, you still have a relation with Cisco, we help you deploy, we help you, fix if there's any problem. That's that's the value, right, for both the customer and Cisco.
Definitely, there's still a role in the support, in CX, all the services, and still that Silicon One and the box itself, because we're talking about tens of thousands, hundreds of thousands now, boxes per customer. So, I mean, even that thin layer of the Silicon One and the Silicon One is a huge advantage here. And even the NPU itself is a selling point. Even if we did not architect the full Sonic layer at the top, the Silicon One at the bottom is a huge selling point, because there are features there that are very important, like the power consumption and some features when we do AI data centers can be crucial to the way we handle QoS and so on. Yes, the NPU is really a key factor in the decision to select one vendor over another in the Sonic world, even if the top part is common.
That was my question. So I'm making an unholy comparison to the old Linksys WRT54, where I think that's where OpenWRT came from, right? People wanted their Linksys More router to do more. And then it became an operating system that you can install on a bunch of random network devices. People loved it because typically those consumer vendors were not developing a lot of features. You know, they had their feature set and they would stop there, not a lot of updates. And the fact you have a community, you have a lot of security fixes, a lot of new features, and people say, well, I install this open source system because then I can have it do a firewall, I can have it do this and this and this feature, and people found a lot of fun. But I thought the enterprise would be the opposite. Like, Cisco has a lot of proprietary features. We know our hardware. We know we can do a lot of fancy features that competitors might not, because we know our hardware. How does that work with an open source? I had the impression you would lose a lot of features.
Yes, definitely, and I believe it's part of it too. It's part of the decision. I mean, if you take a vendor operating system, there are probably features that have been developed for so many years now into any operating systems, some for data center, but some for service providers, for enterprise and so on, which are never used in a huge data center these days. Some switches in the data center do very basic things. They sometimes just switch IPv4 and IPv6 packets, and that's it. If you take a spine in a data center, it's just an IPv4 and IPv6 routers, like we were doing in the 90s when I joined. There was nothing fancy there, and what we do today in a spine on the data center is very basic. We switch unicast packets. So why do we need all these features that have been added to the traditional vendors' operating systems when we don't use them? We could have a very basic Sonic NOS that does just BGP and switches packets, inserts routes in the NPU, and that's about it. So yeah, the features is not necessarily something we need in these data centers, at least not in the spine or super spine. Maybe now there are more features in when we get to top of rack, because there we may have to do features like BGP, VPN, VXLAN, and stuff like that, which is a bit more complex. But we don't need the full set of features that you were referring to. We can simplify and avoid regressions in features that we don't use that could cause us to do constant upgrades and so on. We could have a basic switch that does unicast routing and be happy with it without too many risks of having new bugs introduced.
Do you mind spending a bit of time on the architecture of Sonic? How does it compare to iOS XR or to other network operating systems?
So it's based on Linux as the basement. We install Debian packages on top of it, and we use Docker containers. All the major functions of Sonic are in containers. But it's really coming from multi-pieces. It's kind of a Lego where we have basically each Lego piece would be a GitHub repository. So when you build a Sonic image, there is a main build repo on GitHub, but it's going to pull some code from different places in different repos. Customers would be actually very free to modify it, add their own code, pick different repos. Let's say there is usually in the base Sonic, there is, for instance, FRR for the routing part, and that's where you will do BGP and so on. So there will be one Docker container with FRR. But some very large customers who have a lot of their own developers, they would say, oh, look, FRR, I don't want to use it. I'm going to use my own routing protocol that I will develop based on, for instance, the controller programming the routes instead of relying on a dynamic routing protocol. It's very possible. So any customer is able to build its own image, but there is a base Sonic repo which is based on FRR. There is TeamD for the port channels. There is an SNMP, and there is GNMI for the API. So all the blocks that are used, all the features will have their own Docker container. This is the main architecture. Within the middle of all these containers, there is a Redis container, which is the database, which is really the meeting point between all these containers. This is basically how they do IPC. They will create or delete or update entries in that Redis database, and the other containers will be notified of these addition, create, delete, update, and so on. And that's how they pass information between them. Because as you guess, and as we already explained, there is that FRR that will do the routing. It will install the routes, and so on into that Redis database, and then it will be picked up by our container, which is called SingD, which is the container where the NPU is getting the route, and these routes will be programmed into the NPU. So that Redis database is really the key central piece of Sonic, where all the containers will get their config from and will update their state and the routes and the neighbors and the ARP entries. All these networking objects will be stored into that Redis database and picked up by SingD, which is the container of the handling the NPU. Sonic is really a code that is made of multiple repos, aggregated together, bundled into an image that you will install on top of your hardware box. To install the box, there is another piece of software that is called Oni. That's basically a bootloader, like we had on some boxes. It's an open source bootloader that will install the Sonic image, and from there you can upgrade to newer Sonic images from inside the Sonic container with some CLI command.
You mentioned Oni. That's an interesting point. You cannot install Sonic on every single iOS XR box. It needs to be one that has Oni built in. Is that right?
Well, it depends, because iOS XR on the 8000 will require, for security reason, we have a chain of ownership, and we make sure that any piece of software that we install and run and installs a new piece of software is signed and authenticated with some certificate from Cisco, right? And Sonic being unsigned by Cisco, when customers build in by themselves, we cannot install Sonic and Oni unsigned on these XR boxes, because it will say, oh, look, it doesn't have the Cisco certificate. It's not a valid code. I'm going to stop here. So what we did initially was to create some 8000 with a PID which have -O at the end to say, oh, it's an open PID. I don't need a signed Cisco image. And then a customer building their images by themselves will be able to run their code, their open code on them. So yes, to be able to run Oni and Sonic on some 8000, you need the -O version of these PIDs, basically. That was until recently. For the first boxes that we did, we had the -O, right? Now, recently, we started to support Sonic on the distributed 8800, which is basically the one with RPs and line cards. And this one were at some customer, they were running iOS XR, and we said, okay, well, it would be nice to be able to run XR for some time, and then during a maintenance, we convert them to Sonic, and they keep running after the conversion, right? Swapping an existing XR box requiring signed images, which is sometimes huge. These distributed have multiple line cards and RP. These are big boxes, and swapping them to a -O version would be a huge effort. So what we do now is a transfer of ownership for these big boxes, the 8800, the distributed ones. We share some certificates to be able to transfer the ownership of that box to the customer, and then the customer owns the box and is able to run their signed Sonic images. These customers can still sign their images, but it will run on some boxes which used to require the Cisco certificate when it was XR. But now they sign their images and they are able to run their signed Sonic images on these boxes. So that's the recent new models that we have for the distributed Sonic. So that in that case, there is no more -O. It runs on the plain PIDs that we use for XR. Same.
That's interesting. It's actually a good feature to have. Talking about distribution or distributed system, actually, based on the container approach of Sonic, I have the impression that you could run some part of it, like the Redis DB, outside of the router itself. Is this possible, or does this require to be run on the box?
Anything is possible, but today it's running on the box. Each Sonic router has its own set of containers, and actually on these distributed boxes there will be multiple routers per NPU. There will be a little Sonic router per NPU, because there are lots of NPUs in a distributed chassis, and we will have one Sonic router basically talking to the other one through BGP, through the fabric, and one Sonic router basically per NPU. This is the different, a very key different architecture on our distributed box, is that in XR it was just one integrated router with one BGP instance running on the RP. Here, each NPU is basically one Sonic router, and it's very much like if there was multiple pizza boxes inside one big chassis. This is exactly this is very, for simplicity. This is very easy. There are lots of peering between these routers, but when we support the pizza boxes for the top of rack and the spine, then when we get to the super spine with distributed boxes, it's just like if we had multiple pizza boxes, just like for the spine inside the chassis, basically. And they talk over the fabric through BGP, and it's just pure IP end to end. There is no more cells like we used to have between line cards and so on. Now it's pure IP packet over the fabric. We can run BFD between the NPUs over the fabric and so on. So this is a key difference in the architecture of our implementation of Sonic on the 8800.
I have the impression, based on what you said, that it would be very complex to configure, like lots of components in all different places. So what's the targeted approach, or the approach that we or the industry recommends to configure a Sonic box? Is there like a Sonic CLI, or do we need to APIs to program that?
There are multiple options, and yes, because there are pieces coming from different components, there are different ways to configure it. You can configure it with the Linux CLI to add an IP address, or do ifconfig up or down like we do on a Linux box. But there is also a config DB table inside Redis with the startup config, if you will. There is a CLI inside the FRR Docker container that allows to configure just iOS-like. If you remember, same CLI that we have in iOS routers and switching, that's available inside the FRR container. You can configure it, of course, through automation. You can use GNMI to configure it and stuff like that. Automation is key, because we are talking about data centers for some customers with more than 100,000 devices. So automation is key. So there are multiple ways to configure it, which is very different from our vendor boxes, where there is, maybe now there is CLI and automation also for these vendors, but usually it's more user-friendly, and I would say in these vendors, because we try to help the user with the question mark and stuff like that. Here, it's kind of assumed that we have advanced users, and I would say it's not the goal of Sonic to be user-friendly, to be configured manually. We have lots of ways to configure it, because we assume that there will be a good engineering team that will take one of these options for what they need and then automate it. Nobody's going to go to a data center and configure thousands of boxes manually, right? So you will do it through GNMI, through automation. You will have a controller uploading the config. You will do maybe a zero-touch provisioning when it boots up, but it must be automated at that scale. There is no chance that you can manage a huge data center of an hyperscaler manually. So yes, there are different ways. It's a bit, if you load it for the first time, you would say, what are all these ways to configure the same thing through the Linux CLI, the IP address, IP neighbor, and these commands. ifconfig up and down. You can configure through the config DB, through the FRR. why do I have so many ways to configure it? But then in the end, it's just the customer that will say, what's the easiest for my controller that will configure that device, because nobody's is going to do it manually. It's always through automation that we do stuff on that box.
That makes sense.
Key difference, the scale is really, I mean, for anything you think about Sonic, you have to think about the scale. This is managed by really small teams, and that's supposed to be super stable. You've got, I mean, with so many devices, you've got to be stable. You've got to be to use automation to configure it and manage it. You've got to automate all your processes when we detect an hardware failure, do an RMA and so on. All this must be automated and required low effort, because it must be automated and be able to be managed with a very small team at a very high scale. This is the key difference. I mean, Sonic must be able to be used at very high scale. So even for me, I've supported tens of thousands of devices being deployed, and all the escalation were coming pretty much to me for the first 3 years. Because Sonic is supposed to be very stable, and yeah, we will, due to that huge scale, we will see some, I mean, what can go wrong will go wrong at that scale. So I will get some very one-off issues that are, of course, escalated, because we've got to be careful when we have that scale, that if we were to have a software bug, for instance, you can be sure that it will spread to these tens of thousands. If it spreads to all these boxes, you're really in trouble, right? So you better catch these software bugs or the hardware bugs if you have systemic hardware failures. I mean, you've got to be careful and catch them early and address them carefully. So any issue is super important. We have to deal with any issue as a mini crisis. Almost immediately, anything is an escalation, if you want, because if it spreads to the majority of the boxes, then we're in deep trouble. So yeah, the key is for any new image is to start small, deploy it in a data center with low traffic, make sure it runs, and then we can scale it to the rest of the tens of thousands or 100,000s of devices in some customer networks. So yeah, this is a key aspect of Sonic. It better work. Yeah, it better be simple to troubleshoot, because the scale would be a huge issue if some issue was to spread to many boxes.
Since you're talking about the scale, I actually remember 10 years ago or something like that, Facebook, to name them because they're public, said, we're tired of these proprietary boxes. We're going to go, they call it white box at the end, and do our own operating system, our own configuration, our own stuff. Like, we're going to self-manage our data centers. And I think they're still doing that. Is that the type of customers who want to run Sonic just because you have a lot of scale? So you say, we don't need, in a lot of places, those fancy features. Like, we have enough scale that automation for us is a no-brainer. And, the complexity is not a problem. We'll just automate it and then it's going to be simple thanks to the scale. Is that a type of customers who are interested in Sonic? Smaller customers, like, it's not intuitive, it's not easy to configure, so they might want.
Definitely, it's the sweet spot for Sonic to start with, and it's where it's starting. You mentioned Meta, Microsoft Azure. Microsoft is the one who created Sonic, open source it after some time. So now it's open source and it's coming from Microsoft. So all the architects of Sonic are coming from Microsoft. Meta, they did another approach, is to have their own NOS. They call it FBOSS, I believe, and at the bottom it's the same. It will be the same SI layer for APIs to program the NPU, but they will have their own code on top of it. This is the kind of deployment that we see with these hyperscalers, because they have the size to be able to have their own developers supporting their own FBOSS for Meta, or Sonic for Microsoft or others. And some others will say, okay, I'm taking Sonic, but I will replace the routing container with my own. Yeah, they can still be based on Sonic, but not the full Sonic. They can customize it for their needs. For the smaller customers, then it's easier to take a full Sonic image from a vendor like Cisco and deploy it and be supported by Cisco and so on. And that's where services play a key role and so on. I'm sure that these smaller customers will follow the lead from the big ones, because they see, well, look, these huge customers are able to deploy so many boxes at relatively low cost, because it's an open source operating system. Why not me? They will say, and I'm sure that they will try to follow the lead of the big hyperscalers. So I'm sure that it's a trend that we're going to see to more and more customers. And some of them, and some smaller customers, I mean, it will never be a sweet spot because, as you mentioned at the beginning, they need so many features that will never make it to Sonic. I mean, it's currently, at least, it's very designed for data centers, and it will miss lots of features that you want to do in some other places in the network. Maybe over time it will spread to more and more the WAN and so on. Who knows? But for now, it's very much designed for the data centers, and it's easier for a large player than a smaller one. But I'm sure that they will follow the lead of these hyperscalers over time. They will want to try it at least.
The more people adopt something, the more secure it is, because a lot more people test it, a lot more people fix it, especially if it's open source. So it's more reliable, more secure, the more people use it. And then if enough people use it, it can also become simple to use and so on and so on. But it all comes from adoption, right? So
yes, I'm sure there will be and it's a very active community. I mean, there will be enhancements when smaller players want to contribute and so on. They will make a feature request to make it more user friendly and stuff like that. It's not that it's not user friendly, it's that you have to learn the different ways to do stuff in Sonic, because it's so many, there are different ways to do stuff. Yes, and I'm sure the newer customers will have feature requests and stuff like that, and Sonic will evolve. I mean, just like any operating system for switches and so on, there are feature requests, there are new features in every release. I mean, there are multiple releases per year, and each time we get new features being added. So it's evolving. I mean, it's not static. There are new features in every new release, and the newer customers using it, the more customers will get, the more features there will be, and it will become more deployable for the smaller customers, I feel. Yeah.
Maybe a trick question, but since XR was built in the first place for service provider and large customers, is there still a future in XR if we have Sonic that's growing up on the other side and that has other advantages?
Yeah, well, the service providers still require lots of features that are not in Sonic and might never be in Sonic. So service providers, I mean, they use tons of features. When you see all the features that we have in XR, there is still a huge advantage for XR over Sonic for service providers. Now, if service providers have data centers where you have that class topology with leaf and spine, then Sonic is a good fit for this. When you see an SP and all the features that they use, L3 VPN, EVPN, and all these features, I mean, there are still lots of features which are not there today that service provider can enjoy with XR. Over time, we will see if Sonic can catch up for the WAN and Metro and so on, where XR is being used. Today, I mean, it's still XR for these service providers or even the hyperscalers between the data centers. They still have some XR devices, because XR in the WAN or for SPs still lots of features that are not there in Sonic. It's more for data center at this point, Sonic.
Is it correct to say that I'm making comparison with the enterprise world, which I'm more familiar with? In any world, there's a whole number of customers who are a lot into owning their network. So they have a really skilled team. They want to customize. They want the network to be efficient, automated. So those are the automation nerd, if I can say so. And then you have another group of customers who are like, I'm not really interested. I want a minimal team. I want a solution that works. I want something easy, like you're the vendor, like own it. And that's where we have sometimes, cloud solution, but even on-prem that, are simple to deploy. They come with the whole management and automation suite. Is that the same in the service provider? Like there's those two types of customers, and one is not better than the other. It's just a different management style, a different network type.
I think it's a mix of the two options that you mentioned, because they want to customize, yes. So we could say it's the first option, but at the same time, they need to make it simple and automate it and so that it can be scaled to a huge number of devices. So yes, they want control over the network, decide which features they use, decide how they will manage it from their controller and so on. So yeah, they definitely want to manage that aspect of the network. but they also want the simplicity. Definitely, if something goes wrong, they want the support of the vendors and so on. So yes, they want control, but they want also simplicity for something that is easy to deploy, manage, scale, and that's also a strong point of Sonic. It's easy to scale it to lots of devices in a data center. So yes, I think it's a bit of both. I would say simplicity to be able to scale and automate, and customization at the same time. They want to be able to do whatever. They can add their own agents on top of Sonic in their own Docker container. That's fully supported. They have the full ability to do that, and they do it. I mean, they have their own containers on the box that we don't support, of course, but it's fully possible to do any customization that you want to do.
Simplicity to operate on a daily basis, but maybe a steeper learning curve, right? When you deploy the first time, but once that is deployed, it's like simple on a daily basis, right? You can make changes like without a problem, and the scale is not the problem then.
Make changes, that's the key to me to scale. It's to not make changes. I think it's really the key. The way to make it successful is to have the exact same topology in every data center across the world, the same feature set, no config change. No, that doesn't exist in Sonic. Every device has the exact same config, exact same feature set, exact same version that has been tested and is stable. I mean, that's the key. So you're not going to add a new BGP route policy in the middle of the network. That doesn't exist in Sonic. It's just every single device is doing the same as it's been designed to, and that's really starting with a test suite. When there is a new role in the network, the Sonic community and customers will create a set of tests for this role. So let's say a customer wants to deploy a Sonic spine, let's say. There is a Sonic test that's called the Sonic Management Suite, where all the tests for what a spine is supposed to do will be created. We create all the tests, and when a new vendor wants to say, hey, I'd like to be the spine in your network, they will say, well, you pass this set of tests that we have for that role, and when you have passed it, then we will consider your device for that role. And then the vendor might start at 10% pass rate or something like that, and over time they will develop their product, and at the end it will be passing all the tests, and then it will be ready to be deployed. But that series of tests is exactly the way that this device will be configured. It supports exactly the traffic that will go through that box, and that's the way we can make sure that there is not an outage as soon as you deploy that new box in that huge data center, right? No, I mean, this is really a mindset that you have to adopt when you move to the Sonic world. Every single box must be the same. You're not going to configure an access list in the middle of the network out of the blue manually. That does not exist. If there is an access list, it has been configured by the controller, and it's the exact same on any Sonic device. That's really the key to scaling and stability, I would say.
That's true for every network, right? When I meant change, I meant a business change, like rolling out a new application, or like the business is changing. You know, we're now operating in this country, we're not operating before, whatever. For the network, it should not be a change. It's like, oh yeah, it's just more of the same, right? Like, we don't need to change our config. We just plug more stuff. Like, the network is ready for that, and it's not a change. If every day you have to change access lists, change port config, like, that's not automation. And it's a source of security issues, a source of misconfiguration, a source, like, you cannot operate at scale with that, right? So when I meant change, it's more like, yeah, nothing is a change for you because your network is just the same everywhere, simple, adaptable to your business tasks.
Yes, I mean, I think we were discussing service providers in a few minutes ago. That's a key difference with the data centers, where it's always the same cluster topology with leaf spine and super spine, compared to service providers where they have links in every cities and every street, and it's different in every place basically. So I think, I mean, there would be some benefit for service providers to adopt some more strict topology, like we've seen in the data centers. But that's where you need all these features from a NOS like XR, because there's no two routers with the exact same config in the service provider world. Depending on the type of link you have there, you have this small customer with a low bandwidth link, and then you have next to it you have another huge bank with a high-speed link, and the features for the bank are not the same as for the residential customer. No, in the data center world, it's what it's really making it success. It's really fixed topologies, fixed configuration, always the same kind of traffic that goes through. That I was saying, it's basically for a spine, a basic IPv4, IPv6 unicast router. I mean, that's it. Simplicity, and that allows reliability and scale.
I have a tricky question, a very marketing, manager type of question. A lot of products, a lot of vendors are doing like AI fancy features. What about Sonic? Is Cisco bringing like crazy, fancy features that interoperate with our hardware to Sonic as well, or that is just kept for iOS XR? Like, is Sonic, sticking to basic features, or is all the new, emerging technologies like segment routing also in Sonic?
Segment routing is coming in Sonic for this AI traffic. Sonic is a key enabler of the AI ML traffic that goes through Sonic. Definitely these huge data center, what we call the backend network, where GPUs are talking to each other at high speed, at full bandwidth. I mean, the GPU, when it starts transmitting, it would get to line rate at 400 gig in no time, right? And Sonic, and most importantly, the NPUs that are below Sonic must be able to handle this traffic from the GPUs at very high speed and with quality of service, because there is always pretty much RDMA over control internet, RoCE traffic, and PFC and ECN. So really, Sonic and the NPU used by Sonic is really a key aspect of AI, but it's more to allow these GPUs to talk to each other at super high speed with QoS. So this is something I see every day. These PFC and ECN and so on transferring the AI traffic. I mean, yes, this is done by Sonic, definitely, and Sonic is a key enabler of this AI traffic between the servers.
If people want to get started and know more about Sonic, where can they go?
Yeah, on the developer.cisco.com, we have some guides for Sonic. We also explain how to load Sonic in some VMs and so on. So it's possible to learn there. I would load Sonic in a VM where you simulate the NPU, the Silicon One NPU, and then you can configure BGP between two Sonic instances and see how you configure it, get the look and feel. Start there. Then there is the Sonic community, all the documentation this is all on the internet on some GitHub repos. For Cisco, I would start on developer.cisco.com, the Sonic section on 8000. And then also all the community stuff.
Thank you. That was super insightful. Thanks a lot for spending time with us today.
Cool. That was fun.
Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us on the Cisco Podcast Network in SoundCloud or your favorite podcasting app. You can also find us on our own channel called Cisco Tech Stories in every podcasting application. We are also on X at Cisco Tech Story without the S, and on Instagram and YouTube at Cisco Tech Stories. Thanks, and see you next month.
Pizza boxes in my chest.